Hey, what is up, guys? Nice job today attacking that test, giving it everything you had. Love to see the effort. It was great. Today is day 31. Back into some more notes rather than just review problems. So once again, these notes will be important to take. Make sure you take them well so you can show me tomorrow, and make sure that you are working towards understanding on this. We're going to work on our introduction to PVA. It's going to be a short video just because I don't have a lot of time today. I call it PVA. It's for position, velocity, acceleration. So you learned about position, velocity, acceleration in physics class. Some of you have already taken AP Physics, or you are taking AP Physics right now. So this should not be a totally foreign concept to us. We're looking at this again. So this works with position time functions, velocity time functions, and acceleration time functions. Because these are functions of time, they're going to be functions in terms of t and instead of in terms of x, like we're more comfortable with. But just treat t like x and treat whatever the other one is like y. So let's talk about position first. For position time functions, they use three different letters that I see. Either x of t, y of t, or s of t. I have seen all three used on the AP exam, with probably a little bit more preference towards either x of t or s of t, but occasionally they do y of t as well. All right, so this just gives you the position at a specific time. So if we see this written, x of 5 equals 9, this means at t equals 5, the object is at position 9. That example didn't have any units, but that's how we read that. X of t, or x of 5 equals 9. At time t equals 5, the object is at position 9, right? Oftentimes this is kind of like on a number line or something like that, or sometimes they put it in the context of a word problem, like a distance between two towns, or a location of a train. The position time function, this gives location of the object. So whenever we want to know where an object is located at a certain time, we want to use the position time function. Sometimes they put units on these. Oftentimes t is in seconds or minutes or hours or days or sometimes years. The position is given sometimes in meters, sometimes in centimeters, sometimes in inches, sometimes feet, sometimes miles. Could be any of those things. Usually in physics we're only working with meters and seconds, but that is not the case on the AP Calc exam. Okay? So that's our position time function. It just gives the location of an object at a specific time. So let's say at time t. Okay, so that's our position time function. Very important. Does not give the distance traveled, it only gives its location at a certain time. Okay, next. The V is for velocity. So a velocity time function, they use v of t, by far the most common. Sometimes they'll give you v of t for one object, and then they'll introduce some other person, like Chris, and they'll say Chris's velocity is given by c of t. So just be aware, occasionally in problems where they have multiple v of t functions, they'll give you, they might use a different letter. or they'll use V1 and V2 for the two different objects. Okay. So let's take a look at velocity time function. So what does that do? This function gives you velocity at time t. Okay, so if I say v of 3 equals -15, this would read at time t, at time 3, the velocity is -15. In terms of velocities are often a mix of positive and negative numbers, right? That positive or negative only indicates direction. So if we say a velocity of -15, that means it's going 15, but to the left, if it's a left-right problem, or it means it's going 15 down, if it's an up-down problem. Don't confuse velocity with speed. I want to take a second right here and talk about speed. Really important thing to remember about speed is speed doesn't care what direction you're going, right? We have speed limits on our roads, not velocity limits, right? It says speed limit 60. You can't be going 70 and heading west and say, oh, sorry, officer, I was actually going -70. The speed limit is 60, right? No, your speed was 70. Speed doesn't care. Speed is always positive. So to find speed, we can simply do the absolute value of velocity. They get really tricky on the test on questions about speed. So just always remember, when in doubt, speed is always positive. It's the absolute value of velocity. Okay? The A is for acceleration. Oh, by the way, units on here. Units might be meters per second. It could be feet per minute. It could be miles per hour. Any distance unit divided by any time unit. Go back and add units to your position time. Units could be meters, feet, miles, yards, whatever is a distance unit. All right, acceleration. So an acceleration time function is A of t. So this gives you the acceleration at time t. So if I said A of 0 equals 5, that means at time 0, the acceleration is 5. Units for acceleration, we should know these from physics, but just to be careful, meters per second squared, miles per hour squared, we could see feet per second squared or feet per minute squared. It's always a distance unit divided by a time unit squared. Okay. Great, now how do they relate? Well, think back to physics class, right? When you were given a position time graph and you needed to know the velocity, you found the slope. When you're given a velocity time graph and you need to find the acceleration, you found the slope. Well, how do we find slope in calculus? Well, we do that with the derivative. So here's an important table. If I want to move from x of t to v of t, or from v of t to a of t, I need to do a derivative, right? Derivative allows us to find slope at any time. So to move down this ladder, I have to do a derivative. I'm going to say d dt instead of d dx because our variable here is t. Okay. So in other words, the derivative of my position time function is equal to velocity. V prime of t would equal what? Well, that would be the derivative of velocity, follow the loop, is a of t. Another question for you, what would x prime prime of t be? What would x double prime of t be? Well, if I did two derivatives on x, I would go all the way from position to acceleration. One quick example. Let's say a positional time graph is x of t equals 4t cubed minus 2t squared plus 6t minus 7. By the way, when you write the letter t, make sure you make it different than the plus sign. Okay? Important there. So what I want you to do is I want you to find b prime of t, a prime of t, v prime of 0, and a prime of 2. Okay. Oops, sorry. I just want v of t, a of t, v of 0, a of 2. My bad. So I want to find an expression for v of t, for a of t, for v of 0, and a of 2. Sorry if you already wrote that in there. Okay, so to find v of t, I simply need to do the derivative of x of t. Once again, it's going to be very important that you label things very well, just like in our first unit, because you get a lot of functions going on here. Keep them labeled, say v of t equals, don't just write it out. Don't write an expression, write an equation. Okay, so v of t would be the derivative of x of t, so that would be 12t squared minus 4t plus 6. So that's our expression for v of t. A of t would be another derivative, so that would be 24t minus 4. To find v of 0, I'm just going to plug in 0 for t, and I'm going to get 6. No units in this problem, so I don't need to worry about it. A of 2, it's going to be 24 times 2 minus 4, which would be 48 minus 4, which is 44. Okay, again, no unit. So that's it for today, kind of a quick one, but we'll dive into some practice problems with this tomorrow in class, and we'll get a more in-depth video on what the problems are going to look like tomorrow. Again, awesome work today, guys, on your test. It's really good to challenge yourself with some difficult problems. Whether you get it right or wrong, it's good. It's good practice. Talk to you later. Bye. 2 chains.